Okay, this is project number 3, video number 3, the one in which I do the documentation, cleanup, labeling the graph axes, etc. So let's switch over to edit. Let's try a window, plot trajectory. This is the one I'm working on. Just going to try to go by memory and then check the handout. Use that as a checklist. So we're supposed to say what the function does. First line after the function statement. Start with a function description. And I'm going to go ahead and pause the video while I type that in because you know what the function does. Just describe thoroughly what the function does. I kept it short. Plot trajectory creates a graph trajectory of a particle. I think I said launch. Yeah, launched over flat level ground from above ground level. And then I'll start with the input variables. Percent. We have H. Let's say H is the go equal. The launch height. GHT relative to ground level. Oops. Percent, and then I'll go ahead and type in what the other two variables are. So theta launch angle above the horizontal, plot trajectory returns nothing. So that's pretty obvious from the fact that I used the name unused for the return variable. And then I think I got it there. Call this, I thought I had, okay. Percent y component of the acceleration due to gravity. I think plot trajectory trajectory uses a coordinate system in which x is forward and y is upward. Alright, then this being the y component makes sense. So also anybody that knows what's going on recognizes why it's negative. This line right here, you go percent TF is the time of flight. And you know what? I think no, we'll leave it like that. TF is the time of flight. TF, the following line is the time of flight. Then T array, I go percent array of time values. And then X array, I think that's obvious. Okay. This last part might not be so obvious. To the value determined automatically based on the maximum height projectile. Alright, and what we really got to do is affect what it looks like when you run it. And so we got the plot, we got the limits. Let's go title, and what do I want to call it? Trajectory of projectile. And X label downrange distance in meters, and Y label height above ground level in meters. Alright, let's see how that looks. Try running it. I just saved it, so I gotta go to where I'm keeping it. So fall 2012 projects, my code. Okay, plot trajectory. This launcher from a height of 100 meters at a speed of 50 meters per second horizontally. Let's see how that looks. Alright, break it down, get it down into your field of view here. Oh, I kind of like that. Get it stretched out horizontally, since it only, the max is 100 meters, but it goes almost 250 meters. Height above ground level in meters. Trajectory of projectile. Downrange distance in meters. Okay, I think those are reasonable labels. Probably not the only ones that could be used, but reasonable. And then I think I better take a look at the handout itself and see if I've covered all the bases. So here's the handout, and write a MATLAB function which does that. Launch height, launch speed, and launch angle. Okay, algebraic solution and outline. Check. As for the program point, reasonable attempt. I hope I got that. 1 point if it works right. It seems to do that. Nothing extra to the command window. Nothing extra to the command window. Excellent. Documentation and final touches. Alright. That's a tough point to get, eh? So, graph must be titled and the axes labeled within each hand what's being plotted and the units. So meters and meters should be the units. And I got those, and I got titles, and I got a title for the whole graph too, so I think I'm doing alright there. Your name's got to be in every.m file. I can remember typing that in. But, yep, just to make sure, there it is. Then, code must be documented. Comments stating what the function does. That's supposed to be that first line after the function statement. And, starting in the first line anyway. Plot trajectory does this. Let's see if you can get the whole thing in there. Not really. Unless maybe. Yeah, I think I can get the whole thing in your field of view. Yep, there we go. Plot trajectory creates a graph of the trajectory of a projectile. Alright. I got that. If it takes arguments, comments stating what each argument is. If it returns one or more value, comments saying what each is. Okay. I got the arguments. I got those input values. H, V0, and theta. They're all listed here, what they are. And then I mentioned the output variables, even though there aren't any. For the case of a function that includes segments that aren't self-explanatory, say what they are. I thought that TF needed a little bit of explanation. If you look at the pencil and paper part, it's clear, but other than that, I was thinking of calling it time of flight, but it would have run me off the edge of the page there. Probably would have been better to leave that as VOY. Calculate VOY up here, and then plug it in. It would make that a shorter expression, but I'm okay with it the way it is. What else we got in the requirements here? So I think I did that. You must provide attribution. Whatever resources. I used some MATLAB help. Okay, attribution. We go percent attribution. I forget which one it was. I think it might have been the sign D. Yeah, plot, I know. Yep. Sine D and cosine D. I wasn't sure whether it was D sine or cosine sine D, but it's clear that it's sine D and cosine D. So I'm actually okay if you don't include the MATLAB help file used. It's probably helpful to me to make sure that you guys are taking advantage of that resource. But you can also look stuff up on the internet. Just if I'd have typed in MATLAB sine, maybe MATLAB sine degrees, probably would have found it. But I really stipulate that you have to include all outside resources, and I consider the help files within MATLAB to be inside resources, so you don't necessarily have to put those, but I think it's a good idea. Alright, and I think I'm to the end of the checklist. We're just getting down to documentation, so I think I just put that completely within the whole thing within your field of view. Just maybe scroll through it one more time. Get the function. A lot of documentation. Oh yeah, these lines I didn't think were necessarily self-explanatory. Oh, I looked up ylim. I wasn't aware that you could do this stuff. It was this line right here. I looked up. Use MATLAB help files for use of sine D, cosine, and ylim. And ylim. Okay, I definitely looked that up. I'm glad I scrolled through this to make sure I wasn't forgetting anything. But I did have to, I felt it necessary to put documentation on there as well. Alright, I'm going to save it. I must have made some change since it allowed me to save it, so run it one more time. I guess I'll change these. 10, 5, 88 degrees. Let's see what that looks like. So it didn't go very far at all. Less than a meter. So try to put these guys close to the same scale. Actually, this is still too long this way, but we got the idea. It doesn't go very far at all. It goes almost straight up, comes straight down, almost. Alright, seems to be working. I think I've got it all. I'm going to call this a wrap for Project 3, video number 3.